Okay, so to carry on, I'll go to task 2, where I gave you guys a map sheet 24-28 data set from the National Groundwater Archive. And what I wanted from you was a graph showing the average water strike, borehole, and water level depths, the water strike zones that you could identify if there were any, and then the blow yield versus depth variance, if any, showing was there a variation in blow yield as you had changes in depth. So first thing first, you look at your data set and you can remove data owner and type of feature just to clean up your data a little bit. And then what I do is I split it into separate sheets: borehole depth, water strike depth, water level, and blow yield, just to make it easier to work with. So I've got my borehole depth and I've removed all of the data that was not borehole depth. I've got it all here. Now I want to filter my data just to make sure I remove any duplicates that might exist. So I sort it by ID, A to Z, and then I sort it by borehole depth, smallest to largest. Then I can see here, borehole number 1, there's a problem because it's the same ID and I've got a 6-meter borehole depth and then an 86-meter borehole depth. Now what that could be is that they recorded the borehole depth on day 1 of drilling at 6 meters and then at final depth was 86. So to get around this and to filter my data, well, let's just show you what the impact of that would be. So my average unfiltered data equals average for my data set is 27.69. I'm just going to copy this and paste the value. Average for my filtered data set. So what I'm going to do is I'm going to resort my data. I'm going to keep ID as A to Z, but I'm going to change my borehole depth from smallest to largest to smallest, so that it puts my larger borehole depth value first, which is my most likely final borehole depth. And then I go remove duplicates, unselect my Y and my X. So I want to remove points where the ID and the borehole depth are the same. Oh, no, ID is the same. Borehole depth can vary because you've got the different depths there. Okay, so I'm left with 5,000 unique values and they removed over 55,000 duplicates. I'm going to recalculate my average. And there we go. Look at the difference in our values, showing you the importance of filtering your data sets. Okay, so there's my borehole depth average. Now for water strike, we're going to do the same, sort our data, ID, and then smallest to largest water strike depth. And here we go again, we've got equal values there. But what we need to remember is that sometimes boreholes will have multiple water strikes. So what we do when we filter our data, we go remove duplicates again. But then we choose the ID and the water strike. So to show you an example of this, I will make 21 and 90 or 92 for these two. And then I'll go to remove duplicates, but I'll have the evaluation criteria for the ID and the water strike depth. Okay. You see it's removed all of the duplicates for these cells, but it's kept my unique values here. If I undo all of that, do it again. See, then it's removed these duplicates. You can see here for borehole 30, I had water strikes recorded at 49 meters, 82 meters, and then 88 meters again. So that's why you need to make sure you have both criteria checked. Okay, my average water strike depth is 50 meters. Then the water levels. You can see the duplicate values. Again, same ID, same date, same depth. So therefore it is a duplicate. But remember, you can have different measurements on different dates. So we go to data, remove duplicates, and we want to evaluate our duplicates on water level date and water level. So it's the same date and the same water level. There we go, 4,000 removed. That's there we go. So we filtered that. So my average water level is equal to 8.4. Okay, so that's question A. My average water strike, borehole, and water level depths. Now we want to determine the water strike zones, if there were any. So I go back to my water strike depth spreadsheet. I know my average is 50, but now I want to determine what's my minimum. So we go min, range, and then max, range. So my water strike depths vary between 0.6 and 476 meters, which is quite a spread. So now the first step to getting my water strike zones is I determine my bin range, which is to create my histogram. So I'm going to say first bin would be 5 meters, 0 to 5 meters. Let's just check our 75th quartile, so quartile inclusive, my array. I'm going to choose the third quartile, 75%, which is 70. So 75% of my data set occurs below 70 meters. So I'm going to make refined bins up to 70. Then I'll go up to 10 meters. 25 meters, then 50 meters. And I'm just going to leave it at 200 because most people don't want to drill past 200 meters. Remember, my average borehole depth is 50. So these are probably outliers that are going up to 400 meters. Then you go to data, and you should have the data analysis add-in activated. If you don't have this, you go to your file options, you go to add-ins, and you go Excel add-ins, analysis toolpack. Then it'll add it onto your data ribbon for data analysis. So I'm going to click on that one. I'm going to choose histogram. My input range is my data. Then my bin range I've just defined. You can do output either to a new worksheet or just on the same one. We define it to be put there. You say, okay. So my bin for less than 5 meters is 30 counts. So we can do a sanity check on this if we want to. We go equals count if. Now select my range. And my criteria would be less than 30. Doesn't work. Never mind. So this would be 10 to 15 meters, etc. Then this is more than 200. So you can see there most of my data is below 200 meters. Only 5 borehole points had a water strike more than 200 meter depth. So I'm just going to do this quickly. This is just to label my graph, makes it a bit easier. Okay, then we construct a 2D bar graph, which will show my frequency of water strikes per zone. So I'll select my data. I'm just going to call it water level depth. Select my frequency data. Then my labels will be my bin ranges. Then I just format my axis to go into reverse order, just to show from ground surface going down. Makes it a bit easier to read for what it is. Okay, so in this data set, you can see the majority of your water strikes fall between 15 and 30 meters. So we'll just draw a shape on there. So there's the one water strike zone. And then secondary water strike zone would probably extend down to from 30 meters all the way down to 50 meters. And then you've got a tertiary one down at 70 meters to 125 meters. And after 125 meters, you've got a big decrease in frequency. So these are the 3 water strike zones. You've got one main one, because you see it's more than 300 water strikes per zone. This one goes above 400. So the majority of your data sets is falling in here. Secondary there, and tertiary here. So we've got 3 water strike zones, 15 to 30, 30 to 50, and then 70 to 125. That is the water strike zone question. Blow yield depth variance. Okay, the way we do that, we've got our blow yield, and we've left the water strike depth in here. I'm just going to remove this. Okay, so in terms of blow yield, we've got both the total blow yield and then the water strike seepage value. you can see here, water strike seepage, where you only have seepage, they don't include it as the blow yield. So we just have to filter our data set again. Select your data, so data, sort it first by your seepage, then by your blow yield. So we can see where we have and haven't got data. Let me just remove our blank data sets just to make it easier to interpret the data and run your formulas. So you can see here, we've got seepage and blow yield, but it's at the same borehole. So it's at water strike 10 meters and then water strike 45 meters. Both of them were seepage, giving you a total blow yield, a cumulative blow yield of 0.0002, which is that plus that. Okay, so we've got to be careful when we filter our data sets again. So we go remove duplicates. Let's forget that. Let's look at where there is only seepage. You see here, there was seepage of 0.01, but it wasn't recorded as part of the blow yield. I'm just going to sort my data by the IDs. And then equals if, so I'll just do it visually, equals if this one is blank, then it's that one, otherwise equals this one. So what that means is that if this is a blank, then we'll take the water strike seepage value, or we'll just take this one. So we've got that. Now you can see where this one, we had the seepage value, but we didn't have a blow yield. Now we have a blow yield value. Yeah, I'm just going to move that over there. Now we're only dealing with one column of data. Okay, so we've got here, we've got a water strike depth of 20, blow yield of 0.45, and then again duplicate there. So remove duplicates, but we want to remove the duplicate where the ID, the water strike, and the blow yield are the same. So, okay, there we go. So it's left only one of these two. But on the other ones, like for example, this borehole 30, where we had different water strikes, it's given us the different blow yields. It's given us the total blow yield. Okay, so now what we want to do, we've got our 3 water strike zones. We've got one from 15 to 30, then 30 to 50, and 70 to 125. So the easiest way to do this in your blow yields is to say blow yields at depths less than 30, which will incorporate everything in this zone. Then water strike depths more than 70, which will incorporate everything after this. And then water strike depths 30 to 70. It's not specific, but it's the easiest way to get an idea. Does my blow yield increase after or in our water strike zone? So you go average if. So my range of the if function would be my water strike depth, less than 30. My criteria is less than 30. And then my average range is my blow yield. Just have to figure out this function. So let's just say if that is less than 30, it falls into zone 1. Or if it's more than 70, falls into zone 3, or it's in zone 2. Easy workaround. So now say equals average if, and then my range there. My criteria is 1, so zone 1. Then my average range is there at my blow yields. So there we go. My average blow yield for zone 1, which is less than 30 meters, is 2.4. Yep. Just fix this to make it easier. So function, you just say F4. F4. So all we're going to change is the middle criteria. So it's zone 2. And then zone 3. So you can see with depth, you have a decreasing blow yield. Our most successful or high yielding zone is the less than 30 meter zone, followed by 30 to 70 meters. But if you drill past 70 meters, you've got almost a liter per second less blow yield on average. So that answers section or task 2, section C.